Okay, so in this video about Chapter 5, we're talking about connective tissue, the functions of connective tissue and distinguishing the types and the location where each one's found, and then the components. So the components, what makes up connective tissue, why is it a connective tissue, the functions of it, and different types where we can find it. So connective tissue is the most diverse tissue, abundant and widely distributed. It has many different roles, but collectively it's to support, protect, and bind organs. Connective tissue has three main parts. It has the cells within it, the protein fibers, and then the ground, what's known as the ground substance. We're talking about tendons, ligaments, adipose tissue, fat tissue, cartilage, bone, blood. Those are all connective tissues. And again, the three basic components: cells, protein fibers, and ground substance in connective tissue. So cells, different classes have different specific cell types. Most of these cells, compared to like epithelial tissue, these cells are not in direct contact with each other. The cells can either be resident cells or wandering. So resident cells are stationary. They're within that connective tissue. They're going to support it, maintain it, and repair the area outside of the cells. So some examples of cells that are resident cells within connective tissue. Very important kind is called a fibroblast. Flat cells with tapered ends. They're the most abundant type of resident cell within the connective tissue. They produce the protein fibers, so like collagen, and they produce the stuff called ground substance of extracellular matrix, so the stuff outside the cells. Another example of a resident cell is an adipocyte, which is a fat cell. So adipose tissue is made up of adipocytes. Next one. A mesenchymal cell is an embryonic stem cell that's found in mesenchyme tissue. Another resident cell is a fixed macrophage. A macrophage is a white blood cell that is phagocytic, will ingest particles, and they're dispersed through the matrix of the connective tissue, and they sit there waiting to engulf things to phagocytize them, possible pathogens or damaged cells. Wandering cells do what you think they do. They continuously move through the connective tissue. They are cells of the immune system. They come in to repair things when needed. They are leukocytes or white blood cells. So mast cells, which we'll talk about. Don't worry about learning all the details of these wandering cells right now, because in the immune system, we will talk about them in detail. But they're all immune system cells, so they come in, leave. Mast cells, the two cool things they do is they secrete heparin, which is a blood thinner, and histamine that dilates blood vessels, involved in the inflammatory response. Plasma cells make antibodies, which are for protection. Free macrophages are phagocytic, mobile. They'll move in and out of tissues, blood vessels. Other leukocytes, neutrophils, also phagocytic. And then T lymphocytes attack. So those are different cells that can be found in connective tissue, and it can vary depending on the type of connective tissue. But they have cells. They all have cells. And then all connective tissue has fibers, these protein fibers that strengthen and support that connective tissue. The three main types: collagen fibers, reticular fibers, and elastic fibers. So first, collagen. They are cable-like long fibers. They're very strong and flexible, resistant to stretching. Appear white in fresh tissue. So we're going to see many in your tendons and your ligaments. Your ligaments connect bone to bone. Your tendons connect bone to muscle, so they need to be very strong. We also have collagen in our skin that makes your skin tight. We lose some collagen as we get older. Another type of fiber is a reticular fiber. They are very similar to collagen, except they're thinner. They are very flexible. And we're going to see a lot of these type of fibers in the lymph nodes, spleen, and in your liver. And the last type of fibers are elastic fibers. They contain a protein called elastin that, think of them, write down elastic fibers. Think of them as I'm trying to look if I have one, a hair tie. I have one in my hair. I'll do that. Okay, so a hair tie stretches easily, and then it bounces back to its original shape easily. Elastic fibers, able to stretch and go back to their original shape. They're yellow in color when they're fresh. They help structures go back to normal after stretching, thus elasticity. So we have a lot in your skin, your arteries, because arteries contain blood that's under high pressure, and in your lungs when the lungs get larger and then they recoil back to their original shape. The last feature of connective tissue is ground substance. So we're not talking cells within it, we're not talking the fibers, but we're talking about everything else. Ground substance can either be viscous, like in blood, semi-solid, like in cartilage, kind of like jello, or solid, like bone. So anything outside the cell. So if we have a bone cell here, here's a bone cell, it's round, it's called an osteocyte. Anything outside of that is called extracellular matrix. This includes the fibers and then the ground substance. This ground substance, the stuff in between the fibers, can be liquid or semi-solid or solid. I'm going to tell you that you don't focus on this. Let's just ignore the details about the ground substance here, about the GAGs and the proteoglycans and the glycoproteins. Here's what connective tissue looks like. Generally speaking, we have cells. Here's the cells, some examples of adipocytes, fibroblasts, macrophages. Here is our protein fibers. We have elastic, collagen, and reticular, and then we have ground substance. Okay, and this is a good figure to refer to. Clinical connection, scurvy. The pirates back in the day had to worry about getting scurvy, which is abnormality with collagen in your connective tissue. Not enough vitamin C in the diet, which the pirates didn't have because they were on ships for long periods of time. They could get scurvy, so a weakness in collagen. Collagen is meant to strengthen and support your body tissue, so if you don't have enough vitamin C, it's going to cause it to become loose, weak. So symptoms, gum ulceration, abnormalities in the gum, hemorrhages, abnormal bone growth. Okay, to fix it, you eat foods high in vitamin C. So pirates used to stockpile ships with limes to prevent scurvy. The functions, why do we need connective tissue? Physical protection. Your bones, which is a connective tissue, bones is to protect organs. Your fat, which is a connective tissue, adipose tissue, protects your kidneys. Your kidneys are surrounded by fat. Your eyes in your eye socket are surrounded by fat. They support in the structure of your body. Again, the bones, ligaments, tendons that attach bone to bone, muscle to bone. Cartilage, keep it open. Cartilage in your trachea, these rings that you feel, that is connective tissue, cartilage. And then around your kidneys and spleen, you also have connective tissue. They also bind structures to other structures. Like I mentioned, ligaments bind bone to bone, tendons bind muscle to bone. Also store things. Adipose connective tissue stores fat for energy. Bone stores calcium. Transport. Blood is a connective tissue that transport respiratory gases. And then immune protection. Leukocytes within it help with the immune system. Just making sure where we are. Okay. So there is embryonic connective tissue within an embryo skeleton. There is mesenchyme, and then there's mucous connective tissue. Mesenchyme develops into pretty much everything. It's the first type of connective tissue in the embryo skeleton. And it's the source of all other connective tissues. As adults, we still have some mesenchymal stem cells that can help repair tissue. Second type is only in the umbilical cord, and it's um, very cool looking, um, jelly-like. It has more protein fibers. This is what it looks like. So mesenchyme is in the embryonic skeleton. Mucous connective tissue is in the umbilical cord. The mucous connective tissue is often can be saved for future stem cells. Another genetic disorder or problem with connective tissue is called, in this case, it's a genetic disorder called Marfan syndrome. So again, it's inherited, and it's a disease of the connective tissue. What happens is the connective tissue is weakened as a result of abnormal chromosome 15. Causes your skeletal system to be different, cardiovascular system to be weak, and problems with vision potentially. So what they look like: abnormally long fingers, toes, and limbs. It has been rumored that Abraham Lincoln had Marfan syndrome. So kind of think of the way he looked, elongated. Um, thoracic cage isn't properly made, doesn't look right. Joints that become easily dislocated because of weak ligaments, weak connective tissue, right? Where it really is bad to have weak connective tissue is around the heart. It causes the valves and the big blood vessels around the heart to be weak. So death usually occurs due to cardiovascular problems before the age of 50. Okay, but a longer lifespan is a result of early diagnosis and treatments. Like I said, all of the connective tissue is derived from mesenchyme, and it can be divided into two categories: connective tissue, loose connective tissue, and dense. And in the next video, we'll talk about the different types of loose connective tissue and types of dense.